data structures using C, linked list implementation of a queue. In a last exercise, we did a linked list implementation of queue. There what I did was I just gave the front, the, and then whenever we wanted to insert a new node, we traversed through the whole list, added a list new node at the end of the list. I want to modify this program a little. So what we will do in this exercise is we will have a link for the front node, and also we will have a link for the rear node. So we'll have the front and the rear. So we will delete the node from the front and we will add new node at the rear. So this is how we won't traverse the list, but we will just add a node at the rear of the list. So let us see how it is to be done. So in this lecture, therefore, we will implement the linked list version of the queue with front and rear pointers. Write functions, we have, as you have written earlier, almost the same function, enqueue and dequeue, and to input data and to delete a data item from the front of the linked list. Let us see. Write function subprograms to display the content of a given queue. Okay, so this is you are familiar with. Again, enqueue to be done at the rear and dequeue to be done at the front. This is the front, this is the rear. And this is the delete item here, this is the insert item. Insert item is known as enqueue. Deleting an item from a queue is known as dequeue. Again, we have got a queue here. Front is there and the rear is there. We are going to remove numbers from the front, first in, first out, and we are just going to attach the new node to the rear. That's all. Rear next at the moment points to null. What we will say, rear next is equal to new node. That's all. So simple as that. So let us see how it is to be done. Again, basics. This represents the node of a queue. You are familiar with the new data type called queue node, and then we create a new node here. This is a pointer. New node is a pointer of the type queue node. Then we allocate memory to that queue node, a new node, and then we assign 40 to this new node number and say in next points to null. So this is what we are going to do. So here we have that function which you are very familiar with, make queue node. So we have got the new node, local variable. We are assigning memory to that new node, that is allocating memory using malloc. Then we are assigning the number to this number variable, new node number. New node next is equal points to null. So this is how we have created. For example, make queue node 40. Immediately there is going to be a node here which contains, that is new node which contains 40. I'm assigning that address of the new node, this new node, to this node in the program, and this node will have the address of this queue node which is called new node. So here we are. So what is the difference this time? This time what we are going to do is we are going to make two pointers called front and the rear. And we are going to, at the beginning, we are going to initialize both of them to null. Front is equal to null, rear is equal to null. Therefore, if front is equal to null and rear is equal to null, we know that the queue is empty. Or just if the rear is null, it is understood that the queue is empty. So therefore, this is how we are going to do. We are going to initialize the queue, init queue. This is the first function we are making use of in the main program. To initialize the queue is a front is equal to null, rear is equal to null, return. And front and rear are global variables. Please remember, they are not local variables in the main, but they are global variables. And we are assigning null to both of them, initializing both of them to null. So this is how it is. Front is equal to null and rear is equal to null. So, okay. With that, case 1. Case 1 is queue is empty. How do I know the queue is empty? If the rear is null, automatically we know that it is empty. Therefore, you attach the new node to rear and also the front, because it is empty. When it is empty, the first node is going to be the front node and also going to be the rear node. So that is what we are doing here. So same node is assigned to front and the rear and return. So that is case 1. Case 2 is very simple. So what we do is we create a queue node. If queue node is empty, make that node the front and the rear of the queue. That is what is done here. So case 2 is very simple. Unlike earlier case, we traverse to the list. Just simple. You attach the new node at the rear. Rear next, you say the new node. So for example here, so create a queue node. That is first we are creating a queue node. If queue node is empty, make that node the rear and front of the queue. That is what we have done earlier. Case 1. Then otherwise insert the node, the new node at the rear of the queue. So now rear points to this node. So what do I do therefore? I say rear next. This is new node is created. Rear next is equal to new node. That is what? This is rear. Rear next is equal to new node. Immediately earlier it was pointing to null. Now the rear node is pointing to the new node. Now you have to make this one rear. Till now this is the rear. That is what we do after this. So what we do is we say rear is equal to new node. Therefore the address, early the address of this node was the rear. Now the address of this node, which contains 95, has become the rear. So we have simplified therefore the whole queue with having these two, front node and the rear node. So that is what we are doing. So okay, so here is the code now, enqueue. So if rear is null, so make rear and the front the new node which is created. Otherwise you say rear next is equal to node and rear is equal to node, that is new node. So simple as that. With that we come to dequeue, deleting. So we have to delete this node as we have done earlier. So front node. So get the value of the front node, that is I'm getting here. Node is equal to front. Then make node next, that is this node next the front of the queue. So that is what we are doing here. First you've got the number, node number. Then you are making now node next as the front. So that is node next now. This is node which contains 30. That is next. So we have put this number here. We have done this number here. Now node next is equal to front. That is front is equal to node next. And then free this node. So we have removed that node from the list. So this is how first assign front to the node, get the number of on that node and put it there, and you return that number afterwards because you want have that number. And you say front is equal to node next. It puts the address of the second node into the front and then it releases this node. So that is being done. So that is due here as you see. So if the front is null, then the queue is empty, rear is also make rear also null. Then otherwise what you do, make the front of the node and then remove that number and put it into number, and you say you make node next as the front, release that free that node. This node is freed, that is head, the front of this list is released, and you get also the number. So this is the function to init the queue, front is equal to null and rear is equal to null. So here printing, you are very familiar. So you assign the front, address of the front to a variable called current, which has queue node. And as long as current is there, every time you come here, print this number. You go here, current next, print this number. Then this becomes current, print this number. When current becomes current next, this comes out of the loop by the time you have printed the content of the queue. So that is given here again. If the front is null, you will say is empty. Otherwise, you go on printing the values of each of the node. So this is the menu function which you are very familiar with. I don't have to explain. So here is the main program, part of the main program. Here is the new data type queue node. The structure type contains number and link to the next queue type. Then you have declared two variables, front and rear. These are the prototypes of my function, and here you run a menu-driven program which you are familiar with. Here it is the thing, menu-driven program. You initialize the queue, then choice is equal to 1, so you are getting to this switch statement. If you enter 1, that means you are entering number. 2 means you are deleting the number and display that number. And if you have 3 is equal to printing the queue, 4 is equal to exit, otherwise every time it is going to show the menu. So these are some of the examples here which I have done. For example, we have entered numbers, then I press 3, so it is shown 4 numbers. Then I have entered the fifth number, so I enter choice. There is a capacity is 5 here, capacity is 5, it is full. Then again I want to, this is delete, I am deleting the number. As you see 23, it is deleted. Then I am again displaying 23 is gone, 56, 12, 89, 78 we have added here. And then I'm adding one more. It is already full. 5 numbers are there. I'm adding one more number. Is queue is full. So this is. I would like you to write this code, enter this code, and test your code and get stuck, because you learn so much when you get stuck with the problem. Otherwise, you don't learn. Sometimes you should spend hours and hours checking and debugging the program. And if you do that, I'm very sure you are going to be expert not only in data structures, you are going to be experts in programming. Good, wish you all the best.